Function notation. Function notation is a notation that gives us two things. It first allows us to identify an equation as a function. The notation for function notation is f of x. And the other thing the notation does, it allows us to evaluate. So if we see f of 3, that means substitute 3 for x. So what we've been doing is we've been given situations such as this. Evaluate when x equals 2, y equals 3x plus 4. So when we have a situation like this, we know we just substitute 2 in for x and we get 10. And then we know the solution is 10, or the point to 10 is on the graph. So now with function notation, instead of writing all this, we can just write f of 2 equals 3x plus 4, meaning this is a function, and substitute 2 in for x. So substitute 2 in for x. So 3 times 2 plus 4 is 6 plus 4. So f of 2 is 10. So when we substitute 2 in for x, we get 10. And that means the point 210 is on that graph. So they're very similar. This is just more of an efficient and concise way to write this. And it will give us a notation later in math to perform operations with functions. So function notation, evaluating functions. So f of x is just a fancy way of saying y. F of x is read f of x. To evaluate a function, all you do is substitute. So when you have this notation, all we're doing is substituting the values in. So evaluate the function f of x is equal to negative 3x minus 7. When f of x is 0, f of 2, and f of negative 5. So we can just substitute those values in. Another way we could do this is go to our calculator and type in our function, negative 3x minus 7. And I can hit trace. So the first one says evaluate, or f of 0 we want. What is y when x is 0? So I'm just going to type 0 in, and y is negative 7. So f of 0 equals 7. Okay, go ahead and do f of 2 and f of negative 5. All right, so I can just type 2 in, enter, and I get negative 13. And I can type in negative 5, and I get 8. All right. Given the function f of x is equal to 2x squared minus 5x minus 3, find the range if the domain is negative 2, 0, and 3. So basically they're saying, what's y, what's the range when you have negative 2, 0, and 3 for x? So another easy way to do that is to go into your calculator and the y equals 2x squared minus 5x minus 3. Again, we could trace. When x is negative 2, y is 15. When x is 0, y is negative 3. And when x is 3, y is 0. So find the range. So the values of y such that y is equal to negative 3, 0, and 15. So here we have this discrete graph, not connected points, and we're just going to identify the x or y value. So f of 3, when x is 3, y is 4. When x is negative 2, y is 1. Now find x if f of x is equal to negative 6. So if y is negative 6, x is 1. And find x if f of x is equal to negative 2. So when y is negative 2, x is negative 5. Let's go ahead and try the next ones. Okay, here we have a mapping diagram. We have a mistake here. This isn't a function. That wasn't intentional. So let's just pretend that it's a function. So when x is 4, y is 3. When x is 5, y is 8. And when y is 8, x is 5. And when y is 4, x is 6. We can do the same thing, identifying f of x on a table. F of 3, so when x is 3, y is, when f of 1, when x is 1, y is 2.5. And find x if f of x is 2.5. So what's the x value? Is 1. And when f of x is equal to 1, when y is 1, x is 2. Evaluating in a word problem, the function w of x is equal to 250x represents the words w of x you can read in x minutes. So how many words can you read in 8 minutes? In x minutes. So w of w8 is equal to 250x. So 250 times 8 is 2,000.